Hi, I'm Rachel Thompson from the Geo Research Institute in Ottawa in Canada, and I'm going to be taking you through some of the things you need to think about if you want to do a systematic review of treatments for the Solv-RD Treatabolome project. And this talk is just going to cover the basics, but if any of you think that you might want to take on a systematic review for the diseases that you're interested in, please do get in touch with me or with any of my colleagues in this workshop. I've put all of our contact details at the end of this presentation. In this talk, I'm going to take you briefly through the background of why we think systematic reviews for rare disease treatments are important, and then I'm going to give you some pointers on how to do a Treatabolome systematic review for your diseases of interest. So what's the concept behind our systematic reviews, and why might you want to do one for the diseases that you specialize in? Well, we know that there are still very few therapies that address the underlying cause of a genetic disorder, but there are actually quite a number of rare diseases that do benefit from some kind of treatment, whether that be a drug treatment or a dietary intervention or even a medical device like a pacemaker. And there are some genetic defects that might mean a patient is at risk of harm if they take a certain drug, where it could actually make their condition worse. This information is often available in the published literature, but sometimes it isn't that easy to find. We all know about the diagnostic odyssey, where patients don't get a confirmed diagnosis for years, but in some cases it can also be that a patient does have a diagnosis but wasn't put on a treatment because the doctor making the diagnosis didn't find the evidence in the literature that said that a particular drug might be useful. So if we can make that information more readily accessible, we can help decrease that gap between diagnosis and treatment. Let's give you an example from the first Treatabolome systematic review that we did. This is a little girl with a congenital myasthenic syndrome, which is a genetic neuromuscular condition that can be caused by defects in any one of over 30 genes. Congenital myasthenia causes problems with the transmission of the nerve signal at the neuromuscular junction, the synapse between the nerve and the muscle, and the phenotype you have with CMS is fatigable weakness and often additional things like ptosis, ophthalmoplegia, and breathing difficulties. In this first photo on the left, you can see the girl's trying to raise her arms above her head, and you can see that she's really struggling with that. That's about as far as she manages to get at all. And although you can't see it in this photo, she also has difficulty getting up from the floor, and she can't climb stairs. So her weakness is really affecting her daily life quite a lot. And because the weakness is fatigable, if you ask her to do the same action again, the next time she does it, she finds it even more difficult. You can also see that she has quite a bit of facial weakness and she can't actually keep her mouth closed. Quite a few congenital myasthenic syndromes respond to esterase inhibitors like pyridostigmine, and patients are quite often tried on esterase inhibitors even before they get a genetic diagnosis. But this little girl has a mutation in the DOX7 gene, and that's one of the genes where using esterase inhibitors doesn't help and can actually make the condition worse. So patients with DOX7 mutations should actually not be given pyridostigmine, and instead they tend to do quite well on salbutamol and other beta-2 adrenergic receptor agonists like ephedrine. In the picture on the right, you can see the girl after around 6 months of treatment with salbutamol, and although it's difficult to see the full extent of the improvement from a still photo, you can tell that she can raise her arms much more easily. She can keep her mouth closed, and she looks quite a lot stronger generally. She's still not as strong as her peers, but she's actually able to climb stairs, she can get up from the floor, she can go to a normal school, and she can generally participate in activities much more easily. And that's just one example of a drug that has quite a dramatic effect, and where patients with mutations in one gene should not be given a drug that's commonly used for patients with other forms of the condition caused by mutations in different genes. Now, if you're a clinician or a researcher with a special interest in a particular group of genetic disorders, you've probably already come across examples of treatable patients like our congenital myasthenia patient, and you probably also know of patients who should have received a particular intervention but didn't get it soon enough. And that's what our Treatabolome project is designed to address. We want to make it easier for the clinical and clinical genetics communities to access the evidence for treatments for the disorders that they're diagnosing. We want the information that there is a potential treatment available to be flagged up so that the doctor can see it as soon as the patient is diagnosed. And that largely means getting the data out of the published literature and into a format where it's more accessible and more searchable, where it's readable by computers and can be called up as part of clinical decision support systems. It's important to stress here that the decision on whether or not a particular treatment is appropriate is still very much in the hands of the doctor. The Treatabolome database should just make the doctor's life easier by leading them directly to the relevant evidence, so they don't have to spend time doing a literature search themselves, so they don't have to dig through hundreds of papers to find the few that are relevant to the patient that they have in front of them. But that's also an important reason to make the reviews that you do truly systematic and not introduce bias. It's important that we're not saying, it's my judgment that patients with DOX7 mutations should be given salbutamol, so I'm going to only look for the papers that agree with that. What you're saying is, when we searched for all the treatments for patients with DOX7 mutations, we found 28 publications in total where treatments were discussed. Here are all 28, and this is what they said. And now, please, as a clinician, use your best judgment to see whether this applies to your patient. So why do we need to do a systematic review? Isn't there an easier way? Ideally, it would be possible for computers to search the literature automatically and link the treatment to the variant or to the gene or phenotype that it works for at the correct level. But some treatments might work only for defects in a specific gene, some might be more limited to a specific variant in a specific gene, or to a specific type of defect across several different genes. Unfortunately, the way information is published in the literature means it's almost impossible for a computer to parse it at that level of detail and extract it correctly and make those links correctly. On this slide, we have an example of that from the congenital myasthenic syndromes. This publication has a case series of 15 patients with recessive mutations in DOX7, which is the same gene that our previous patient was affected by. I've just pulled out data on a subset of the 15, and you'll see that in the first table on the left, with the arrows pointing in different directions, although a human can make sense of it relatively easily, it's pretty hard for a computer to work out that patient A had a poor response to esterase inhibitors, while patient B showed no improvement, or that none of the patients were tried on ephedrine. Then, if you look at the table on the right, you can also see that although the paper does give the genotypic details of each patient, that's actually in a different table in a different part of the paper and isn't directly linked to the information on the treatments. And as a third aspect, there are further details about the response to treatment in the descriptive text, where they're presented in a lot more detail, but again not directly linked to the tables. Peter Robinson and his colleagues in the Monarch Initiative are working on machine learning approaches for extracting data from the literature, and he's going to tell you about their medical action ontology in the next talk. But I think Peter would also tell you that the AI approaches still can't put out the kind of detail we need in an automated way. What I think they will soon be able to do is point you towards papers like this one, so they can look through the literature and tell you this is a paper that says something about congenital myasthenic syndrome and something about DOX7 and esterase inhibitors and ephedrine, but you still have to go and read the paper yourself to find out how all those elements link together. Okay, so publications are not yet machine readable, but they are human readable. That's what they were designed for in the first place, so that's what we have to do. A systematic literature review searches the published literature in a comprehensive and systematic way to extract evidence that helps answer a particular research question. In our case, our research question is something along the lines of what treatments have been described for this condition or gene or variant, on which specific genetic variants have they been tested, and what is the strength of the associated supporting evidence. Each individual element of this question is important. We need to know the specific treatments that have been tested. We need to know the genetic defects that it's been tested on, and we need some way of evaluating the strength of the evidence for the treatment. A case report on a single patient is obviously much less convincing than a randomized controlled trial on a large cohort of patients, but since so few trials have been done in rare disease, we do think that even the case reports are worth putting into the systematic reviews. We just point out that it's a single case report and the clinician can then make their own judgment. So then where do you actually start? Well, first you should decide on the diseases that you'd like to cover. You shouldn't make them too broad or the review will be too onerous, and you also shouldn't cherry pick or you might introduce bias, so try to choose a happy medium. Then you need to think strategically about the diseases that you've chosen and how the genetic defect links with the treatment. It's important to get this right before you start because it might affect the data that you need to capture. Do you have a situation where the treatment's highly dependent on the gene or even the variant that's affected, or is it the phenotype that's crucial and the treatment should only be given if a specific phenotype is present? These aspects will help determine the information that you need to pull out of each paper. Then it's probably useful to read a bit more about systematic reviews and develop an understanding of the principles behind them. We do have a publication about Treatabolome specific reviews that you can read that should be helpful. I've linked to it at the end of this talk. And you can also read a lot of online guides about systematic reviews in general and about specific types of reviews like Cochrane reviews. Then you need to develop your search strategy, and you should aim to develop a strategy that finds all the papers that describe the treatments of your chosen diseases and not too many irrelevant ones. Your institution may have a research librarian who can help you refine your search strategy. They're used to helping people do that. Then you just need to make a start. The main advice I'd give you here is that you should record everything that you do, because you might end up trying several different searches before you find the right combination of terms that works to find your papers, or you might explore several different avenues in terms of disease areas. So write everything down and save all of the search results and be extremely methodical. Finally, I'm going to take you quickly through some of the points in the systematic review that we did on the congenital myasthenic syndromes, where we also set out the Treatabolome concept. Our initial search found over 900 articles to evaluate, and the Prisma flowchart you see here on the left shows how we refined it down to those that we considered in more detail. What's important to note is that we really wanted to make all the data accessible for databasing and for reuse, so we actually provided Excel files of all the results as supplementary data to the publication. So you can download those Excel files from the journal website and you can see what we captured, and if they're useful you can adapt those files for your own needs. So this is the first Excel spreadsheet which lists all the publications that we considered in the final part of the review, where we reviewed the full text of each publication manually. The basic data on each publication is pulled out of the PubMed search, but then we added columns where we captured the treatment, qualified its effect, and captured the precise genetic details of the patients it had been tested on. So if you think back to those tables I showed you with the arrows for the treatment effects, those have been captured here alongside the variant data to show whether the treatment had a positive or negative effect or no effect at all. If there are other aspects that are important in your specific disease area, you could modify this table to list those as well. The second Excel file is a summary of the evidence at the level of each genetic congenital myasthenia subtype. We provide the details of the subtype, the consensus recommendation on the treatment. We classify the level of evidence according to the grade score, and we list all of the publication where that treatment is discussed. This file is already quite useful as it is, because a clinician can go into it and say, well, I've just diagnosed a patient with an AGRIN mutation. What should I be giving them, and where can I find out more? And they can get straight to the details and to the publications where those treatments are mentioned. But this table is also the foundation for the database that Leslie is going to describe, where this information can be flagged up in a diagnostic system, so that when a patient is diagnosed in the system, the person making the diagnosis also gets the notification that there may be a possible treatment. And it's through mechanisms like that that we hope to decrease that diagnosis to treatment gap. And you can find out more about that in Leslie's talk. In terms of further reading, there are lots of very good general guides available online on how to do systematic reviews. But specifically for the Treatabolome, Antonio Atalaya has written a comprehensive guideline that's been submitted to the Orphanet journal. It's not actually published yet, but because it's quite useful for anyone who's working on these reviews, we've made the submitted version available, this link here. Our original paper on treatments for CMS might also be worth having a look at, so that you can compare that with how you would approach it for your own diseases of interest. We are really keen to hear from people interested in doing a systematic review of treatments in their diseases of interest. Antonio Atalaya from Paris is the person who's keeping track of all the interest we've received so far, so do get in touch with him if you'd like to propose a review. And everyone else in this workshop would also be happy to hear from you with questions, comments and suggestions, so don't hesitate to get in touch at the email addresses that I've put on this slide here. I'd like to finish by thanking my colleagues in the lab in Ottawa, in particular my supervisor Hans Lochmüller, and also everyone in the SolveRD and RD Connect projects who supported this work. Thank you all for sticking with me, and please do get in touch if you have any questions.